Alright, this is my third time recording this, so I'm kind of agitated. But this is my project, and it's a children's book for teenagers, or for high schoolers, detailing some physical science stuff by me. First page, mass. Is a pretty hard thing to describe, you know. But I said it's a measurement of how much matter is in an object. An example of mass would be the mass of protons and neutrons in an atom, because they take up space, you know, so they obviously have mass because they are matter. Objects with large amounts of mass may also have a heavy force of gravity on them. And mass and inertia are related because the more mass something has, the more inertia it has acting on it. So, like, if you have two balls, one's 1 kilogram and one is 2 kilograms, and you push both with a force of 1 Newton, the 2 kilogram one is going to travel further because it's got more inertia. The SI unit for mass is kilograms. This is my picture illustrating the inertia through mass concept. Weight's the easiest thing because it's like well, it really is the sum of the weight of gravity on you and the force of gravity on you and your mass. And the force of gravity on Earth is pretty much all the time 9.8 meters per second. And I mean, it could vary a little bit, but not too much. And the metric unit the metric SI unit for weight is the Newton, but I would like to argue that it could be newtons per kilogram, because it's like a force over an area as well, because like gravity's acting all on your body or on whatever the object is. And the force of gravity on Earth is 9.81 centimeters or meters per second, and on the moon it is 1.6 meters per second. Here's my picture. It illustrates how, although both of these things have the same mass, their weights are different on the moon and on the Earth. On Earth, this ball's weight, which is this mass is 1 kilogram, but its weight on Earth would be 9.8 newtons, and on the moon it would be 1.6. Volume is like how much space an object uses as if it were currency, and it couldn't run out, which it can't. But it's a similar property to capacity, and the SI unit for volume is the milliliter or liter or whatever, some form of liter. So for formulas, really the easiest way to get the volume of something is do the water displacement thing with a graduated cylinder. But for arithmetic formulas, you can have length times width times height, which works for rectangular prisms. Or if you have a perfect cube, you could just take one edge or one side and cube that. And yeah, those are some arithmetic formulas. Oh, my picture, because 1D and 2D figures, they have no volume, so I illustrate that. And then a 3D figure like a cube can have volume, so I illustrated that as possible 10 milliliters. Density, you know, it's how much matter is in an object or is in a specific space. So it's like matter over volume, or mass over volume, you know. Pretty easy concept. I illustrate that zirconium is more dense than titanium, because the density of titanium is like 4.5 grams per centimeter, and the density of titanium is like 5.6. So in a volume of 3 centimeters, titanium is going to have more mass. I mean, zirconium will have more mass. By the way, the SI unit is kilograms per liter or centimeter, or whatever you used to find the volume. And finally, dimensional analysis. It's like conversion of units. And in the metric system, really, all you got to do is multiply by 10. That's why it's so easy. And but for the purposes of example, in my example, I used atmospheric pressure units and pascals, and for 1 atmospheric pressure unit, you have 101,352 pascals. So if you have 1.23 atmospheric pressure units, but you want it in pascals, what you got to do is you got to multiply 1.23 by 1,000 or 101,352, and what you get from that is 124,662.96 pascals. And for my illustration, I have a ball. These balls are the same because 9.8 newtons, and as a weight would be 2.2 pounds as a weight. And that's my project. Thanks for watching.